Hello students. So we are just discussing the machine design. So we have just started with a introduction to design. Okay. So we will just start with our video lecture on introduction to design. Okay. So we have just covered two lecture parts. Okay. We are covering third one now. Okay. So we will just start. So in this first unit, so what all contents are there? So that in first unit. Okay. So what all contents are there? That is in first introduction to machine design. So what is machine design we have learned. Then different classification of machine design, that is adaptive design, new design, development design. All that we have discussed in different classification of design. Then general consideration in design we have discussed. That is what is load, what is stress, what is strain. So that all things we have discussed. Okay, then so we are about to discuss stress strain diagram for mild steel. In this part of a lecture we will discuss what is stress strain diagram, then factors governing the selection of factor of safety. What do you mean by factor of safety we'll discuss. Then different concept on different theory of failure, different types of theory of failure. Then we'll be discussing bending and torsional stress equation. Okay, so that is first we have discussed what is machine design. So it is nothing but it is an creation of a new design or improving the existing one. Already existing one is there, in that you are improving, or it is creating a new design, is nothing but a machine design. In this there are different types: adaptive design, development design, and new design. Adaptive means already existing design is there, in that only you are adopting new methods or small methods. If you are using, then it is called adaptive. New design means it is totally different, it is totally new one, new design. If you are researching and finding out, then it is called as new design. Development design is nothing but in developing design, so it includes both adaptive design and new design. You are using a new creating method, new methods also, and you are adopting a small improvement also, then it is called as a development design. Okay, these are major three types of design. So that is adaptive design, development design, okay, then new design, then rational design. And so then we have discussed what is the rational design and empirical design. So based on the formulas and all, if you are using, it is called as empirical design. Rational design means based on the whatever the experience, past experience, okay, and by seeing in industry what is the stress strain, then by that if you are designing, it is called as a rational design. Okay, so then we have discussed what is load. Okay, load is nothing but a force acting on a body, is called as an load. Okay, so that is load. It can be designated by W, that is it can be given by Newton, or it is a force F, it can be given. Then we have discussed what is stress. Stress is nothing but, so whenever you are applying a small force on a component or a body, so it will deform, it will change its shape and size. Okay, by that it will induce some stresses. Okay, that is, it is the ratio of load, whatever load if you are applying on an area. Okay, which area we are applying, that is called as a stress. Okay, then strain. So whenever you are applying a small force, so what will happen, that whatever the body or component will deform, it will change its length. So that change in length to the original length, originally if suppose 50 is there, now it is changed to 75. Then what is the difference? 25. Whatever change in length is 25. 75 minus 50 is change in length. Change in length to original length is how much? 50 is there. 50 is always, it is there only. So that is called as, that is nothing but strain. Okay, so that all thing we have discussed, what is stress and strain. So in this part of a lecture we will be discussing what is stress strain diagram for a mild steel. Okay, if you are considering you might have studied in your MTQC lab and all. So that is, you have already done this experiment, that is stress strain diagram you have already drawn. There you are using a UTM machine and you are loading the component in that, and you are continuously applying the stress. So that is on y-axis we are taking stress, and on x-axis we are noting what is the strain. So that is continuously in a UTM machine you are applying a load, and what is the change in length you are finding. So when you observe the graph of stress strain diagram, this is stress and this side is strain, so it is called as stress strain diagram. So whenever you see this graph, it will cover this graph will be like this. So there is a need of study of this graph, what all these points and what all are there. That study is very important, and this question is very important for exam point of view also. So it is having different points. That is, first point is a is nothing but proportional limit. So what do you mean by proportional limit? This point, a point is there, no, it is called, which is colored in a yellow color. So this point is called as proportional limit. Why it is called proportional limit is, up to this point, up to a point, what happens is, when you are increasing the stress, strain also increases. It is linear. Okay, it is linear. When you are increasing the stress, strain also goes on increasing. So that is called as proportion. Up to this, the whatever the stress is directly proportional to strain, so it will be a straight line. So that is called as proportional limit. Then B, see here you can see B point. B is called as elastic limit. What do you mean by elastic limit is, up to this point, whatever, if you are loading that component, so it will elongate. Okay, and if you unload that component, it will come to its original shape and size. That point is called as elastic limit. Up to elastic limit, what happens, whatever you are applying the load, and if you leave back, if you take out that load, it will gain its original shape and size. Such point is called as elastic limit. Proportional limit means where up to where it is proportional, stress is proportional to strain. So elastic limit is up to this point. It behaves as an elastic body. You might have seen a rubber if you are taking, and if you are applying the load, and if you are leaving it back, what happens, it will come to original shape and size. Previously how it was, it will be same. So like that the material behaves up to that point, up to B point. That B point is called as elastic limit. Okay, next point is C point. C point is yield limit. See, yield limit, or it is called plastic limit, you can call it as. So after this elastic body, what happens is, so it will not regain its shape and size. So if you are applying more force than B, what happens is, it will enter into a plastic zone, where what you mean by plastic zone is, so it will not regain its original. See, if you are applying a load and if you are leaving it back, so it will remain as it is. It will acquire plastic. So it will acquire a plastic zone. So that point is called as yield point. Okay, then coming to D point is the ultimate point. Ultimate point. This point is called an ultimate point. Ultimate strength or ultimate limit is nothing but, see, up to this you can apply a stress. After this you can't apply a force. If you apply a force, that body will fail. That limit is called as an ultimate. Ultimate is maximum point. So that maximum point is called as ultimate limit. So then coming to fracture point. What do you mean by fracture point is, see, this E point is nothing but a fracture point. Up to this fracture point, if you apply any stress of this fracture point, what happens is, that material or that component will break into pieces. So it will break into pieces. That is called as fracture point. So this is the stress strain diagram. So for particularly we are studying for mild steel. So because we are using, so whatever, when you are designing, we are using mild steel component more. So we are studying. So the study of stress strain diagram for mild steel is very important. So you have understood. So A point is a proportional limit, up to where it is proportional. That is, it is directly proportional. Stress is directly proportional to strain. Proportional means if you are increasing the stress, strain will also increase. So if you are increasing 10 Newton per mm, strain will also be, particularly it will be 5 mm, 5 mm, for next 10 also 5 mm, for next 10 also it is 5. It is proportional, both are proportional, then it is called as proportional limit. Elastic limit means it behaves as an elastic body up to that point. If you take out the force, then it will acquire its original shape and size, elastic. So yield limit is nothing but it will enter into a plastic zone. Ultimate point is the ultimate point after which you can't apply any stress. It is called as an ultimate limit. Fracture point is nothing but it will break into pieces. So that stress at which it will break into pieces is called as a fracture point or fracture. That stress is nothing but fracture stress. So that we have discussed. So that is first is proportional limit is from O to A is called as limit of proportionality. Okay, there what happens is within this Hooke's law will come. What do you mean by Hooke's law is within this point O to A. See here you can see from O here, from O to A. Okay, what is happening? It is straight curve. So straight curve is nothing but within this proportional limit, strain is proportionate to stress. Strain is proportionate to stress. So it is directly proportional. So if you are changing stress, it will change, strain will also change. So that law is called as Hooke's law. Hooke's law will not be applied here. Okay, it will not come here. It will come only up to A point. Okay, that limit is called as proportional limit. Okay, so that point is called proportional limit, and that law whatever you are using is nothing but Hooke's law. Okay, then elastic limit, as I told, up to this point B it behaves as an elastic body. Material regains its original shape. If you are applying any force F, then if I are taking that F again, so it will come to its original shape and size. That limit is called as an elastic limit. Then next coming to yield limit, up to the point where plastic deformation will take, plasticity. Here it is elastic, here it is plastic. So this point is called yield limit. So yielding will take place. Yielding is nothing but plastic deformation will take place. And if you remove the force, so it will not regain its shape and size. It will remain as it is. Whatever force you have applied, whatever deformation it has taken, it will remain same. So that point it behaves as a plastic body. So that is called as yield limit. Then ultimate limit. The ultimate limit can be defined as the highest point. It is an highest point after which the material will fail. That is called as the specimen which can withstand that force. After that it can't withstand and it will break into pieces. That point is called as ultimate point. So then coming to fracture point. What is fracture point? The point where, so it is called, it will breaking point, or it is called fracture point because it will break into pieces is nothing but it is called as a fracture point, or it is called as breaking point. So it will break into two pieces. It is nothing but breaking point. So we have just discussed what is stress strain diagram for a mild state. Okay, so mild state. So then now you are studying this is what ultimate stress. Okay, now if I call this as an working stress, if any stress if you are taking here, it is called as working stress. So now we'll just discuss what is factor of safety. Okay, so factor of safety is nothing but it is maximum stress. Maximum means what? Ultimate stress. So maximum stress, it is maximum stress or ultimate stress divided by working stress. If you just divide those both, so then you will get what is factor of safety. So now factor of safety, if you are taking this as 500, okay, suppose if I take this as 1 minute, I'll just take, okay, so I'll take an example here. So if suppose if I take this point, suppose if I take this point as 500, and if I suppose if I take this working stress, you can take any working stress here. If you just take this working stress as 250. So now what is factor of safety? So factor of safety FOS is equal to maximum stress maximum is 500 divided by working, how much I have taken? 250. So how much you will get? So you will get factor of safety as 2. Now suppose if I take factor of safety, suppose this will be fixed, okay, ultimate stress you can't change. So this is 500 if I take, and if I take this working stress, okay, if I say take working stress as 100, okay, if I take working stress as 100, then what I will get? I will get 5. So this is 2 you are getting, here you are getting 5. That is factor of safety. Which safety is more? So that means this safety. If the value of factor of safety is this value, if it is more, then it is more safe. Okay. So here it will be less safe compared to this. It will be less safe. Okay, so factor of safety is nothing but it is an maximum stress divided by working stress, working or design stress. For 100 it is more safe, okay, for 250 it is less safe. Okay, so now what are the factors affecting this factor of safety? So material strength you are looking, so whether it is brittle material or ductile material. So whether, see, brittle is nothing but it will easily break into pieces, where ductile is nothing but you can convert those into thin wires also. That is called as ductile and brittle. So then loading, it depends on loading, what type of loading you are applying, static, impact or repeated loading you are applying. Then mode of failure, okay, so which type of failure, we will study about the failure in the next slide. Okay, then the test result and accuracy, it depends on all these factors. Okay, so then we will study, so concept of theory of failure. So how that any body, if you are taking any component, when you are applying a force on this, see, up to certain extent it will withstand. After, if suppose this force increases a lot, then this material will fail. So that failure types will be studied. So for your syllabus, it is just you need to know which all types of failure are there. So there is maximum principal stress theory is there first, and then maximum shear stress theory. Then third one is maximum principal strain theory, maximum strain theory, and maximum distortion theory. So only you need to remember these theories. Okay, there is no explanation for it. Okay, so for your syllabus, it is only which types are types of failure. That is maximum principal stress theory, shear. See, stress you are using. See, I have told. So I have explained. If you are taking a body, if you suppose if there is forces like this. Okay, suppose forces are like this, and if suppose if I take an example, if the forces are like this, okay, forces are like this, so it is called as tensile, and this is called as compressive, okay, and this is called as shear. Okay, if you are using this method, then it is called maximum principal. If you are using this shear, then it is called as maximum shear theory. If you are using next strain, if you are using, it is maximum strain. Okay, if you are using strain energy, okay, maximum strain energy, or distortion energy, maximum distortion energy theory. See, these are the different types of theory of failure. So you need not go in depth about this. Okay, you should know only the names of this. If they ask an exam also, they will ask. Okay, just write the different types of theory of failure. So you should know maximum principal stress theory, maximum shear stress theory, maximum principal strain theory, then maximum strain energy, and maximum distortion energy theory. See, these are the different types of theory of failure. So we have briefly discussed what all things here. So in this chapter, okay, we have discussed what is machine design, different classification of design consideration like load, stress, strain we have discussed, stress strain diagram we have discussed, then what is factor of safety we have discussed. It is nothing but ultimate or maximum stress divided by working stress. Just remember that formula, okay, and that factors you just remember. 4 factors are there. depends on load, which type of load, and it depends on material, which type of material, whether brittle material, like that. You just remember 4 factors. Then we have discussed different theory of failure, that is 4-5 types of theory of failure. Just remember the names. They will be asking, they will not ask you to explain, they will ask explain different they'll ask different types of theory of failure if they ask for 5 marks. In this, very important is this thing, okay, that is stress strain theory. Okay, so you just take this as an assignment and just try to draw the diagram of stress strain diagram, okay, and write the explanation part, okay, and take this as an assignment question, because it is very important, it will be asked in your exam. Okay, then last part which is remaining is a bending and torsion stress equation. There are 2 equations, there are 2 formulas, okay, which we will be taking in next chapter itself, because when you are studying chapter, there we will be discussing this. So there only theory part will cover this bending. So almost this, okay, first unit it is completed, because it is having only this much theory part. It is having only 5 marks weightage. So it is having only 5 marks weightage. So we have briefly studied what is all these things. Okay, so in this, very important is stress strain diagram and factor of safety. These 2 are very important. So just go through this and just make own notes and just start studying about this. And in next chapter, okay, so we'll be taking shaft. For this you require data handbook, okay, data handbook. So whenever you are seeing a lecture, so you should have a data handbook. I have told already. So it is Mahadevan and Balveer Reddy. Mahadevan and Balveer Reddy. Okay, because without data handbook it is, okay, very hard to understand. So whenever you are studying or whenever you are seeing the video lecture, you should have this data handbook, Mahadevan and Balveer Reddy. So we have just covered the first unit. Okay, briefly we have just discussed what all things. Just make a note of all these things and just start studying. So now in next class, whenever you are going for a next video lecture, so you just have a data handbook. So that is data handbook, Mahadevan and Balveer Reddy, and the calculator and notes, and just start practicing the problem, because as it is a more problematic subject, so you need to have a book and a pen and calculator and a data handbook to study this subject. Okay, so thank you.